Hello, my name is Patrick Dietrich. I'm the CTO here with ConnectTech, and today we're going to talk about accelerating deployment of edge AI systems with NVIDIA. When looking at edge computing, we're talking about moving the processing power directly into the sensor head, such that the computational power is embedded directly in the device that could be capturing the sensor data as well as processing it all in the same spot. You can see from this graphic here, it's a good view of, over time, the percentage of AI-enabled devices by location. There was a time when the vast majority of AI programs were processed in the cloud. You can see that edge computing's value comes into effect when latency is not tolerable and real-time responses are needed. So the number of edge devices being deployed is growing at a rapid rate here. Experts are predicting that by 2023, more than half of devices will be doing their inferencing directly on the device itself. And you can see here that on-device versus gateway versus on-premise server and cloud solutions, that gateway and on-premise servers are really non-existent here. They're not even showing up in these numbers. So as time progresses, the demand for edge devices and their capabilities will only continue to grow. So now we're going to take a look at why so many companies are moving to do their processing at the edge and why AI is done there. So we see this broken into four major factors: bandwidth, latency, privacy, and connectivity. When looking at bandwidth, you can see the number of cameras being utilized is growing daily. There's over 1 billion cameras used worldwide in 2020. There's just so much data that needs to get passed. If you're to pass all that data up into the cloud, it's just really cumbersome to bring that up into the above network. So when we talk about latency, this becomes critical for any safety critical services that require real-time decisions. There's a lot of applications where you simply can't wait for the time it takes to pass the data up to the cloud, process it, and bring it back. So in many applications, latency is a huge factor for driving the decision to move the processing directly into the edge. And then in terms of privacy, there are a lot of confidential applications where even with a secure connection, you can't have the risk to send any data up to the cloud. You really absolutely have to do all that processing on premise such that none of that information needs to be disclosed to any other network. And then connectivity. A lot of these applications, could be in remote areas where you don't want to rely on or cannot rely on any of the existing infrastructure to have a high bandwidth connection up to a cloud connection. So connectivity can be a major limiting factor to passing this data around. Just the ability to do on-device processing eliminates the need to possibly go out and rely on the infrastructure in which your application is deployed in. Okay, when looking at some of the challenges with AI at the edge and deploying this, the first challenge is building a system that can run multiple diverse and complex neural networks in parallel. These neural networks need to be updated on a regular basis based on new data and new models. So it's critical for the system to not only support today's models, but models of the future and over the lifetime of the product. The second is selecting a platform that includes and accelerates the critical parts of the system to meet real-time edge AI application needs. Many systems integrate and fuse data from multiple sensors that is then processed by deep learning algorithms. Finally, the data is used to take actions and is stored or shared with external systems. The third and final challenge is the ability to develop, deploy, and manage edge AI devices at scale. The nature of AI neural networks and models is that they require regular updates based on new data and use cases. This continuous change is driving the need for embedded systems to be software defined. This is also driving the need to be able to manage a large number of networks of embedded systems, and over time, be able to manage the software on each of these systems in their network. In the edge compute space, the NVIDIA Jetson is one of the leaders, and they truly have a software-defined autonomous solution. Jetson builds on and is compatible with all of the NVIDIA AI platforms for many applications in computing, modern AI, specifically deep learning. So the Jetson software is designed to save developers time and save companies money. The Jetson platform is supported by the Jetpack SDK, which includes board support package, the Linux operating system, support for real-time OS, CUDA, and the compatibility with third-party platforms like the robotic operating system. It comes with libraries for deep learning, computer vision, accelerated computing, multimedia, and supports drivers and a wide range of sensors. NVIDIA develops GPU accelerated IP for tasks that are important for edge devices. As part of Jetpack, NVIDIA provides a rich set of developer tools that accelerate development and provide detailed information about the application and system power and performance, helping developers quickly optimize and tune their code. Jetson software is a continuous investment. On a typical embedded platform, developers are left to pull together all of the separate pieces of software and IP. On Jetson, this is not the case. The developers get a complete SDK, and NVIDIA regularly releases updates with new features and performance improvements. The Jetson software is compatible across the entire Jetson portfolio. Because the Jetson platform is a truly software-defined one, customers can more easily deploy new AI capabilities to the products, even after those products have shipped. GPUs have proven themselves to be ideal for edge computing applications. The inherent structure of the GPU having a massively parallel architecture consisting of thousands of smaller, more efficient cores than a traditional CPU is ideal for handling multiple tasks simultaneously. These GPUs are ideal for these applications where many objects need to be processed simultaneously. So for every unit of energy, GPUs can perform more work than a traditional CPU. When looking at the NVIDIA Jetson platform, Jetson provides a number of computer-on modules which range in performance and power efficiency, ideal for running AI applications. Each Jetson computer-on module comes complete with a CPU, a GPU, a power controller, memory, and flash storage. The benefit of this system-on-module design with NVIDIA has already done the heavy lifting of designing around the chip, which saves customers a lot of time and effort. When looking at the NVIDIA Jetson family, there's a module for all different power performance ranges as well as size and form factor. You can see sort of the smallest, lightest weight is called the NVIDIA Jetson Nano, and it can operate down to a 5-watt mode. And then moving all the way up to the highest performance module, which is called the NVIDIA Jetson AGX Xavier. This can actually operate up to 32 TOPS in around a 10 to 30 watt mode. All of these modules use the same software pack, the same Jetson Jetpack software that we described earlier. When looking at comparing the Jetson platform to other edge computing solutions in the market, you can see that the performance power alone is one of the defining metrics of the Jetson platform, and the ability for it to update and retrain these models from a software-defined flexibility point. Finally, looking at the performance per watt, as well as the price point, it is unmatched by any of its competitors. Customers developing on this platform will traditionally begin their efforts on a developer kit. And this is where you get your kit, AC/DC power supply, and you can plug this in and immediately get rolling. Once customers are ready to move to deploy their products, they'll need to move to a production module. And when you look at the production module, this does not come with the carrier board. It does not come with the thermal or any external storage devices. Typically, be used in these high volume applications. It has a longer life cycle. It is a much more durable and ruggedized product that can be used to fit into a small form factor ruggedized carrier, something that ConnectTech provides, which can be field deployable and has a much more longer life cycle availability for that module. NVIDIA's production modules will require a hardware strategy to be developed. When looking at edge AI hardware strategies, any company with some engineering experience can design their own product, but this is going to come at the expense of your own engineering resources and sacrificing the time to market. So when looking at some hardware strategies to go to market, often one of the best ways to do this is to partner up with one of the NVIDIA ecosystem hardware partners that specializes in AI edge hardware development. So there's a few different strategies that we'll outline here. We have a graph here that describes the level of customization against the quickest time to market. And we've broken this down into three main areas. So first, on the far right here, you'll see an off-the-shelf solution. So this is something that is fully tested and verified. You can deploy this into volume. It's really going to be the most cost effective, but it may not fit all of your custom needs exactly. When looking at modification services, this is typically when you take a commercial off-the-shelf product and just make some minor modifications. So this would be like looking at, for example, one of Connectech's standard off-the-shelf carrier boards, and perhaps maybe just changing the form factor and possibly a few connectors to match up with the cable harnesses that you might need. So that's an example of some quick modifications where you're not having to do a complete redesign of a product. This is going to sort of take down your NRE costs from a fully customized design. It will still allow you for some quick development, but it still may have some limitations for things that you can change. Whereas if you go with a fully turnkey customized design, this will allow you to design something exactly to your product specifications, but this could have additional development time and engineering expense. Expanding on the off-the-shelf solutions for edge AI hardware strategies, Connectech offers a number of integrated subsystems, carrier boards, and thermals. And this is across the entire Jetson platform, so that regardless of where you want to start from an off-the-shelf technology, you can pull in these different components. So if you're looking for something more turnkey that has the full Jetson supercomputer on module integrated with the thermal in a chassis that you can just turn on, then these integrated systems will be the best bet for that. Whereas a subsystem allows you a little more flexibility to integrate this inside your own chassis or mechanical design. And then sort of at the lowest level would be the discrete carrier board option, where a customer can essentially just take the supercomputer on module and integrate it in with this carrier board, and then immediately come with a field deployable solution. And then lastly, looking at the thermals, going back to the production modules that we were describing earlier, each of those production module just comes with either the bare die IC in the case of the Nano and the TX2 and the NX, or in the case of the Xavier AGX, it just has a thermal transfer plate. So a final thermal solution is still required. And those are some of the offerings that Connectech provides. So often your final hurdle for deployment will be to look at your software requirements for your edge AI hardware. So a lot of times customers are busy with their end application and inferencing and perception models that there's a lot that goes into the actual lower level customized board support package that's required. One of the advantages of selecting off-the-shelf hardware from a partner like Connectech is that this will come pre-integrated with a customized board support package, such that it will provide an NVIDIA Jetson module as well as sensor integration. Customers that need to integrate specific sensors that are not part of standard configuration for default board support packages, they can reach out to these hardware partners like Connectech to do the custom integration, such that any image sensor they're looking for can be integrated. I hope you found our discussion regarding the NVIDIA Jetson platforms and its partners informative, and let us know if you have any questions you'd like to discuss today.